Hi all. In this module, we are going to look at enterprise security using Zachman Framework. This module is a self-contained introduction to enterprise architecture, beginning with the basic question, what is an architecture? Later in this part, we are going to introduce the Zachman Framework, the most famous conceptual standard for enterprise architecture. The chapter concludes with a patterns catalog for enterprise architecture problem solving. The contents that we are going to discuss in this module are the Zachman framework for enterprise architecture, primitive models versus composite models, architectural problem solving patterns, under which we will have a look on business question analysis, document mining, hierarchy formation, enterprise workshop, matrix mining, mini pattern for problem solving meetings. Obviously, the questions that strike our minds are, what is architecture? Why do we need it? Okay, for thousands of years, humankind has used architecture to create and reuse buildings. The architecture is the core description of a building. The architecture describes the building structure and all of the building system. When the architecture reflects optimal and effective design, you can make changes to a building with confidence. By knowing the architecture, if you can knock down a wall, drill a hole, or put in a window without causing some catastrophe, such as collapsing the roof, bursting a water pipe, or severing an electrical wire. If you don't know the architecture, or it is a flawed or ineffective, making changes to the building is very difficult. If you make changes by trial and error, you might knock down a wall that is a load bearing wall, which will collapse part of the building. One alternative is to do reverse engineering, that is, the building and recreate the architecture. But reverse engineering is time consuming and expensive. You are much better off if your original architecture is optimally designed and kept up to date, and at the ready for next time you need to make the changes to the building. System architecture is similar. It represents the core design elements of a computer system. Like walls support the roof of a building, some of these elements should support security requirements. Ideally, security should be designed and built into the architecture of a system with inception. Enterprises are complex and changing. Since the textbook, whatever we are referring as this content, we will take the same example. Consider the US Capitol in Washington, D.C. This is an immense legislative building of a very complex enterprise. The US federal government consider the complexity of this building and all the other federal buildings. Then consider the furniture inside, which is movable, the equipment such as copy machines and telephones, and finally the computers that are changing in the real time as new systems are added, relocated, upgraded, and updated. Finally, there are people with their churning organization structure, personal relationships, roles, responsibilities, knowledge, skills, and abilities. The people not only include politicians, government employees, contractors, but also external people and organizations who interact with the federal government, including more than 300 million citizens who are there. The federal government is an organization undergoing massive changes driven by aggressive legislative deadlines and other environmental forces. Because the government needs to change, they need an enterprise architecture. Every agency has dozens of architects maintaining their enterprise architecture. and dozens more designing their solution architectures of the systems. They have a difficult task, but one that must be done to enable the government's need to change. The US Capitol is one complex building in a very complex dynamic enterprise. To represent this complexity in a meaningful way, you need an enterprise architecture framework to guide your analysis. The Zachman Framework is a widely used intellectual standard to analyze and represent enterprise architectures. The Zachman Framework for Enterprise Architecture. Look at the figure. Please remember, try to save a picture of this because most of the concepts that we are going to discuss hereafter will take reference from this figure. The Zachman Framework was invented by John A. Zachman. It's an intellectual tool for describing the enterprises. Because the enterprises are inherently complex, you need a powerful framework to describe them. A framework that divides and conquers the complexity. The Zachman framework slices and dices complexity into rows and columns. The columns are the 6 basic questions you could ask about any subject. These interrogatives include what, how, where, who, when, and why. These are the same questions journalists ask to write the newspaper stories. When a journalist has answered these 6 questions, he or she can claim to have a complete story. The Zachman framework further slices and dices the complexity into rows. The rows represent a general overview of the human roles. The hierarchy of every complex enterprise has executives, business management, architects, engineers, technicians, and users. Each of these roles can ask the same 6 questions, hence 6 cells per row. Each row column intersection in the Zachman framework is a cell to be populated with the models and specifications, which are representations of the enterprise. Everyone has their own specifications. A populated row represents the enterprise architecture from that row-wise perspective. Primitive models versus composite models. A primitive model is one that only includes the entities from a single column. Row 1 contain lists of primitives from each column. Row 2 has hierarchies built from those lists, which can be again seen from the previous slide's figure. Keeping the columns separate in our own models has many advantages. It makes the framework conceptually simple. The model based upon the Zachman framework can be simple, and because the columns are independent, you can populate them in parallel. Primitive models are relatively stable and slow changing. For example, consider the information models in column 1 of figure. Our models can include a list of data entities, as shown in row 1, a data hierarchy, which is row 2, a conceptual schema, row 3, a logical schema, row 4, a physical schema, row 5, and record instances, row 6. Certainly, row 6 changes constantly in the implementation, but the other cells would be relatively stable. How often do you change the physical schema requiring the software engineering? Probably not that often in most of the enterprises. Composite models combine the primitives from multiple columns. An example is a matrix that shows relationships between primitives, such as processors versus data, With that matrix, you can answer the question, which processes use which data? Composite models are necessary for accessing impact between the columns, such as what data is manipulated by which processor and for describing the implementations. The next question that strikes our mind is, how does the Zachman framework help the cybersecurity? Within the voluminous page count of the NIST special publications are some useful ideas. NIST SP 839 recommends the establishment of an organization wide risk management activity. This activity is responsible for enterprises risk executive. The risk executive is a key stakeholder in enterprise investment decisions, in particular information technology investments. The risk executive is not a part of IT shop but provides a business management perspective on risk, which is root 2 of the architecture. The Zachman framework empowers the risk executive to have visibility in the enterprise in the context of making wise decisions in order to manage the enterprise's security risks. The risk executive ensures that from inception, every decision leading to an IT project and an IT system will consider security risks from day one. Security requirements, that is, controls, will be factored into the system design upfront, just like all the other requirements. In effect, systems will be developed with visible security requirements. That is a dramatic sea change from today's business as usual. What happens in practice today, at least in most of the organizations, is that security is first considered when the cybersecurity certification testers arrive, which can be visualized from no time for security anti-pattern, which was discussed in our previous module discussion. There is a mad scramble to issue developers their own accounts, replacing the shared administrative account and other last minute ad hoc measures to pretty up the organization's security posture. Because the security situation is so profoundly broken, certification testers are often drawn into helping the developers re engineer their systems to be secure. Unfortunately, this happens too frequently. The Zachman framework can change all this. Every organization should have an enterprise architecture, a blueprint for change. The risk executives uses the enterprise architecture to assess the risks, levy the security requirements, and ensure continuous monitoring of implementation. Everyone has their own specifications. Zachman Framework is the periodic table of enterprise models. It is a scientific abstraction that helps you manage the real world. The true value of the Zachman Framework is the realization that everyone has their own models. If the models are not meeting your needs or you don't know how to organize them, you can reorganize them using the Zachman Framework. The model should answer all the important questions from your perspective. You can use the Zachman framework from any perspective as your baseline framework to take inventories of things and concepts, organize and define them, and then interrelate them to assess effects, find commonalities, and understand structure. If you have no better way of describing and understanding your world, the Zachman framework is a fruitful starting point for documenting it. And that's architecture regardless of the level where you find yourself. After you understand your architecture, you are in a feasible position to change it. Imagine You are a government IT security professional and you have framework that's very effective for you. You probably have a system security plan, a plan of actions and milestones, a certification test report, and an accreditation letter. These are the items you need to answer all the important questions from your perspective. It means you have a documented architecture, which is a blueprint for change. The gold mine is in row 2. Row 1 of Zachman Framework contains exhaustive lists of enterprise things, which are not inherently useful by themselves, but when they are turned into hierarchies in row 2, you can visualize your enterprise and can navigate to the clusters of commonality. Imagine every type of data your enterprise manages, or every role in the enterprise and every system. Seeing this kind of information helps the business management, which is the road to perspective, make informed recommendations for executive decisions because road to models help the people visualize the enterprise. You know, you now have a new basis for fact-based decision making. For the first time, you see the enterprise game board and can make agile decision based upon your newfound knowledge. Frameworks for row 3. In row 3 of the Zachman framework, which is the architect's perspective, you must ask, do we know how to describe our enterprise and its systems? If you can't answer that question, you proceed further through the Zachman framework and populate the 6 cells on row 3 with architecture models. The matrices relating entities in different columns then become your viewpoint correspondences. Many organizations, however, do have a clue about their choice of frameworks. For row 3 models, people in US Department of Defense choose the DoD architecture framework, an ever expanding amalgam of viewpoints and model types. People in commercial industry might choose the open group architecture framework, which contains expensive descriptions of design methods. People in North Atlantic Treaty Organization would choose the British Ministry of Defense Architecture Framework. These are some of the most widely used frameworks, but there are many more. The row 3 frameworks generate mostly composite models which contain independent viewpoints. The Institute of Electrical and Electronic Engineers, that is IEEE, has captured this concept formally in the standard IEEE 1471 recommended practice for architecture description of software intensive systems. From an international perspective, there is a standard and universally applicable row 3 framework. This framework is jointly standardized by the International Telecommunication Union and the International Standards Organization. It is a reference model for open distribution processing. RMODP. The RMODP and the industry consortia driving its usage. The Telecommunication Information Networking Architecture Consortium are the reasons you can make a phone call from New York to New Zealand through dozens of telephone systems made by different vendors. The telephone systems are interoperable because RMODP constraints are legally enforceable. This is a framework you should seriously consider using for your row 3 architecture perspective model. Architectural problem solving patterns. People have been applying the Zachman framework pervasively since its public release 2 decades ago. An early method documented by Stephen Spivak in the classic book Enterprise Architecture Planning explained how to populate the first few rows with models. It was a laborious process, easily taking 6 months or even more. And the business benefits of doing the exercise were not exactly clear, but the customers' sweat equity should create a psychological buy in. 20 years have passed and the techniques have evolved through thousands of engagements. The key techniques are as follows: business question analysis, the first one. This gathers the knowledge from enterprise subject matter experts to find out what questions the business management has. Analyze each question to understand which columns are involved to answer the questions and which columns needs to be mapped to which others. This analysis determines which hierarchies and matrices are needed. Next we have document mining. Obtain as much enterprise documentation as possible, choose a column and go through each document finding examples. Keep a list of what you found, the enterprise's text defining it, and the document and page number where it can be found for traceability. Completing the document mining for all the interrogatives will populate row 1. Next we have hierarchy formation. A play of card on the wall exercise with small groups and organize each lists into a hierarchy, possibly inventing some new categories in the middle of the tree. Redraw this electronically and print it as a ready readable poster. When complete, you have 6 hierarchies that populate row 2. Next we have enterprise workshop. Bring the posters and some binders with the Roman definitions to a workshop with enterprise stakeholders. Have the enterprise take ownership of the meeting and walk through each hierarchy to validate the models. This workshop is usually done one hierarchy at a time. Finally, matrix mining. Carefully review the documents for cross-column relationships, that is, a sentence involving more than one column. Keep track of each relationship, including document, quoted text, and page number. Then conduct an enterprise workshop to validate the matrices. These techniques use the documents rather than interviews because documents are multi-person vetted content. Interview results are less reliable because they depend on a single person's opinion in whatever situation that person is in that particular day. All this will be looked in detail in the upcoming slides. Problem solving types. Please look at the figure. In the following catalog of the architectural problem-solving patterns, there are primary modes of thinking, that is, divergent thinking, convergent thinking, and information sharing. These correspond to generating ideas, selecting ideas, and defining ideas. Now we shall discuss in detail the architectural problem-solving patterns. The first one is business question analysis, which is also known as classifying the primitives by Zachman column. Problem solving type is convergent thinking. Process rules is by the task lead. Content rules, principal architect, business SME. Communication techniques, small group discussion, individual problem solving. Range of duration can be 1 hour to 3 days. Background. The Zachman Framework is best used to organize the enterprise architecture models to answer important questions from business owners. Preparation needed is business SME documents the key questions from the business owner. Procedure: gather knowledge from enterprise SMEs, for example, experienced based modelers, to find out what questions the business management has. Analyze each question to understand which columns are involved to answer the questions and which columns needs to be mapped to which others. This analysis determines which hierarchies and matrices are needed. Next one is document mining. It is also known as document analysis. Problem solving type is divergent thinking. Process rules: task lead experienced in EA problem solving techniques, principal architect as methodology SME. Content roles: the team. Communication techniques: individual document inspection, document findings with traceable sources, a range of durations, 1 day to 1 month, depending upon the collection of documents. Background: interviews are a weak data collection technique because the information depends on one person's opinion, which varies by their personal situation each day. Customer documents are usually multi-person products that are vetted. The EA consultant is on safe ground if he always maintains traceability to document sources. Preparation: collect as many customer documents as possible. Establish criteria for what is to be collected and how much to collect. The next one is hierarchy formation, also known as cards on the wall. Problem solving type: convergent thinking. Process rules: task lead experienced in EA problem solving techniques. Content rules: the team. Communication techniques: small breakout discussions with cards on the wall or table, and subsequently using Excel and Visio to create the diagram. Duration will be half an hour to 2 hours. Background: interviews are weak data collection technique because the information depends on one person's opinion, which varies by their personal situation each day. Customer documents are usually multi-person products that are vetted. The EA consultant is on safe ground if she always maintains traceability to the document sources. Preparation: put the names of primitive entities generated by document mining onto sticky notes or printed in a large font and cut into separate pieces for tabletop exercise or sticky wall. 28 point Times New Roman works for tabletop. 72 point Times New Roman works for sticky wall. Include some information that ties each primitive back to Excel listing. That is the row number or the source of the document name, and the page number. Procedure. Play a cards on the wall exercise with small groups and organize each list of primitives from the document mining into a hierarchy, possibly inventing some new categories in the middle of the tree. Redraw this electronically and print it as a readable poster. When you complete, you have 6 hierarchies which populate row 2